Hello, everybody. We're going to be talking about the counting principle in more detail. We talked about it yesterday, and here's the problem we actually did yesterday. It says, consider flipping a standard coin. And if we flip a standard coin, we either get heads or we get tails. Now, that's all well and good. Now, we also roll a standard die. Now, think about this. If I were to have rolled the die, I could have gotten a 1 or a 2 or a 3 or a 4 or a 5 or a 6. And all of that could have happened if I got heads first on the coin. Then I say to myself, well, what if I didn't get heads first? What if tails came first? Well, if tails came first, I could have flipped tails and a 1, or tails and a 2, or tails and a 3, or tails and a 4, or tails and a 5, or tails and a 6. So that is how I started my tree diagram yesterday. So this is what the tree diagram would have been like. And I think you guys can imagine actually doing that. I hope you can. So we also said that we would know if we did our tree diagram or we listed our sample space correctly by using the counting principle. And the counting principle then would take the outcomes for a coin, and then we would multiply that by the outcomes for the die. And we know the coin has 2 outcomes. Let me just move that over a little bit. We know the coin has 2 outcomes. We know the die has 6. And together we should get then 12 outcomes, which we do. If we count the branches, we have 12 outcomes, or you could have made this as an ordered pair. Now here they write all of that in math terms. This means the number of items in the first event. The first event was the coin, the number of items was 2. So this looks a little scary, but you could always go back to this. N means number and E means the event. But let's take a look at the cafeteria. All right. So in the cafeteria, you can order a daily special consisting of a drink, a salad, and an entree. Now, the students have 5 drinks to choose from. So we have 5 drinks. And then we have 4 salads. And then we have 3 entrees. Well, I multiply all of these together. 5 times 4 is 20, 20 times 3. That means there are 60 different, dinners that can be formed. So you can there's 60 different ways you can put together what you want to eat in this cafeteria. Let's do another example. Let's look at the word hyperbola. Now, none of the letters are repeating, and so this hyperbola has 9 letters. So we have 9 letters of the alphabet. None of them are repeating. And that matters to me, because it says here, without replacement, we want to create a 4-letter code. Now, okay, so I'm going to have four things in this code. Now, there are some stipulations. Determine the number of 4-letter codes that would begin with 2 vowels. Now, why is a vowel here? So if we look, we have E, we have Y, we have E, we have O, we have A. We have 4 vowels. Now, if we're going to make a code where nothing repeats, that means that we have 4 vowels to choose from for my first event. And then if we chose a vowel, there's only 3 vowels left. So now I have 3 vowels to choose from. Then I have two letters from the word hyperbola already used. That leaves me now for the other 2 choices with 7 letters left to work with. I pick a letter, then finally I have 6 letters. So if I multiply 4 times 3, 12, and then 12 times 7, 84, and 84 times 6, I am going to end up with 504 4-letter codes that I can make. So 504 4-letter codes can be made. So you have to think it through. Now, one of the things you're going to notice as we do a few more of these is I'm going to actually write myself some little spaces and some blanks. So we'll get to that in a moment. But right now, again, you had 9 letters. Your first letter had to be a vowel. There were 4 vowels. And then you picked a vowel. So now you have 3 vowels left to choose from for the second part of the code. Now you took 2 letters out of hyperbola, so that left you with 7 letters. You picked 1 here, and then you had 6 letters left, and you picked 1. And that's important to say because that's going to set us up for the permutation, which we can find on our calculator. So when we have specific arrangements, they're permutations. Now, it's an arrangement, and the word arrangement is so important because when you have the word arrangement, that means the order mattered. So right now, underline this word arrangement. A permutation is an arrangement, and now we're going to write ourselves a little note here, and we're going to state this means order matters. The order matters. Now we're going to eventually look at things where the order doesn't matter, but right now it matters. Consider the letters in the word cat. There's only 3 letters in cat. 2-letter codes are to be made. List all the different codes you can make. Well, I can do that by saying, all right, I have C followed by A. I guess they use capitals, so these capitals. C followed by A. So that's one code. Then, or I could have said C followed by T. Or I didn't start with C. I started with A followed by C. Or I had A followed by T. Or I started with T followed by C. Lastly, I could have had T followed by A. So I get 6 2-letter codes. Now, if I use the counting principle for this, what I am doing now, I'm going to start using my little bars. My first letter could have been any of the 3. So in these first thing, I had 3 choices, and I picked one of them. So that actually looks like this. Actually, I'm going to draw my lines first, and then I'm going to write on it. Okay. So what this means is I had 3 letters in the word cat, and I picked permutation. When I pick, I take time and I take care. Order matters. I picked one of them. That means I had 3 numbers. And then there were 2 numbers left because I picked one. It's no longer usable. And then I picked one from here. That makes 2. That gives me 6 choices. Now, I could do this with the permutation like this, or the word permutation, since order matters, usually implies that you are not repeating something. So I could have said right from the beginning, from the three numbers that are given to me, three letters that are given to me, I am going to pick two of them. And this, if you go to your calculator, and let's do that, and let's turn it on. Now, hit the word math. Look up at the top. There's that probability menu. So if I click the back arrow, here it is, and here's the permutation key number 2. Now, it looks just like this. So I can't do anything with that right now. If I was going to do this on the calculator, I would say 3, math, back arrow, number 2 for permutation, and then 2. And what the calculator is saying, okay, my N, my number of items I have to begin with is 3, and the R is what I'm picking. I'm picking 2. I hit enter, I get 6. So this is on the calculator, and for every problem we do, I'm not going to take the time to plug them into the calculator, but you should. So there we go. So here is the little bit of notes on that. Oops. They say number of ways to permutate N objects, take an R at a time. So N is the number and R is what we are picking. So if we have 8 pick 3 and you type this into your calculator, you're going to get 8 pick 3. Let's just do that together. Just practice one more time. 8, math, back arrow, 2, and you're picking 3. You're going to get 336. And so what really is happening with 8 pick 3 is from 8 numbers, you're taking 8, you're taking the number before it, and you're taking the number before that. So you're counting down from 8, but you're only picking the first 3 numbers from the countdown, 8, 7, 6. And again, this made 336. So while I'm writing this, why don't you type in 15 pick 2 in your calculator and then see what you get. I hope you got 210, because this again means you have 15 numbers and you are going to pick 2 of them. So you are going to pick 15 and 14, and when you multiply 15 and 14, you are getting 210. Now, type in, if you will, 4P4. 4P4 gives you 24 because you had 4 numbers and you picked all 4 of those numbers. When you pick everything you were given, that's actually called a factorial, and that looks like this. This looks like 4 factorial. And 4 factorial means out of all the 4 numbers you were given, you picked all of them. And there you get 24. Now, if we look at the calculator again briefly, there's the factorial key there. So when the numbers match, you can do 4, math, back arrow. Look at choice 4 as the factorial. It gives you the same thing as if you would have put in 4P4, so you could practice that one as well. All right, let's look at this. 10 runners entered a 100-yard dash. How many different ways could runners finish first, second, and third? Now, order matters here. If you win first place, you don't want the third place medal. So 10 people entered this race, and 3 win, and it's 10P3, 10 pick 3, because order mattered, and you type this in on your calculator and you get 720. So this is actually a really nice little lesson. You have to just think through the problem. The calculator will do all the calculations, you got to think them through. Darla chooses 12 songs for her playlist. And how many different ways could she listen to all 12 songs? So this would be 12p12 or 12 factorial. This is going to be a lot of numbers. So I'm actually going to start typing. So this would be, if I were going to do this, this would be 12. Let me just move this over to here. This would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Yikes. You type that in. I would type in 12 factorial 12p12. You should have gotten 479,001,600. Yikes. 479 million different ways those 12 songs could be shuffled and played. So I'm going to do a couple of the applications because I think the applications were a little bit more difficult to think through on your own than the classwork. So I'm going to do some of the applications and then you'll finish the applications for homework. From a club of 28 students, so here's my N, president, vice president, and treasurer must be chosen. How many ways can this be done? This again, it's a permutation. This is 28 P, 3 people. Type that in, and hopefully you will get exactly what I got, which will be 19,656 ways. That's a lot of ways. But there were 28 people, 28p3. And that's if everybody had an equal chance of being chosen. Now, these are more likely the type of problems you get asked in this level of mathematics. A license plate contains 6 characters, each of which would be either a letter or a digit. Now, guys, there's 26 letters in the alphabet. There's 10 digits. From 0 to 9, count on your fingers, that's 10 digits. So we have to think about this. The sample space for numbers is 10, and the sample space for letters is 26. If any of the 10 digits or the 26 letters can be chosen, determine how many license plates can be created to fit this criteria. Well, that means you had 36 options and you got to choose all 36 of them. Now I'm going to put a P nice and big. Okay, I think this is going to just help me go a little bit faster than trying to write with the, there we go. So 36P36, this now, you type this in, this is a monstrous amount. This is 1,402,410,240 ways that you can pick a 6-digit license plate with all the letters and all the numbers. And they didn't even get more crazy with saying uppercase, lowercase, or characters. Imagine how many different combinations that would be. The first 3 characters must be letters, and the last 3 digits. Repetition of characters is allowed. Now they're putting some conditions on us, and so here's where I'm going to draw some bars. The first 3, these are letters, and then these 3 are digits. Now, the reason I'm doing this, and let me just write this out a little bit. Is because I want to really go through it with you. So now I'm going to have to write with the pen, and let's hope I can do this neatly. Repetitions is allowed, which means out of 26 letters for the first spot, I'm going to pick 1. Now, for the second spot, I still have 26 letters to pick from. And again, I'm going to pick one of them. And then for the third, there's 26 letters. I am going to pick one. Then by the fourth digit, fourth space, I have 10 digits where I'm going to pick one. And then I have 10 digits where I will pick one. And then I have 10 digits where I will pick one. So what this gives me is 26 choices for the first space times 26 choices for the second space times 26 choices for the third, 10 for the fourth, 10 for the fifth, 10 for the sixth. I type that in and I find that I have 17,576,000 different license plates where the first three are letters and the second three are digits. So now if we look down here, we're going to get even more crazy. The first four characters must be letters and the last two digits, so we have four letters now, and then we have two digits, so we have 1, 2, 3, 4 letters, and then we have two digits. Repetition is allowed, but not for the letters. So what they're saying to us here is, you have 26 letters, and you picked one. That brought you down to 25 letters, where you picked one. Now you have 24 letters, where you picked one. And then you have 23 letters, where you picked one. And then you have 10 digits, where you pick one. And you're allowed to repeat, so now there are 10 digits still, where you pick one. What this gives us would be 26 times 25 times 24 times 23 times 10 times 10. And we end up getting with this 35,880,000 different ways we can now do a license plate with this condition placed upon us. Now here, the first character must be a letter and the last must be a number with no repetition. So now they only put a condition on the first, which I'm going to do right away. The first one says out of 26, I must pick one. Then I have the second and the third and the fourth and the fifth, and now I'm at the sixth where I have 10, and I must pick one. Now there's no repetition allowed. So there were 26 letters and 10 numbers. That meant there were 36 items. I picked one of them here and one of them here. That now leaves me with 34 characters where I pick one. And then I'm left with 33 where I pick one. And now I have 32 where I pick one. And then I have 31 where I pick one. So this gives me 26 different things times 34 different things times 33 times 32 times 31 times 10. And this condition gives me 289,386,240 different ways, different combinations. So here, this is what I'd like you to do now. I would like you on your own to do 3 through 8. So now that's 5 problems on your own, and let me know if you need help. Good luck.